we've talked about all of our different transformations, but today we're just going to focus on using all of them together. So we have to decide what transformations are being used, and then maybe I might rotate something and then maybe reflect it and see where it ends up. Okay. So an example is this first one. Okay, it says what transformations happen and in what order did they occur. So I have to decide which was the first transformation that happened. So I need to figure out what shape is my original shape, and then what is the next shape. Okay, so in this picture, what is the original shape? The top right. Very good, JJ, because it doesn't have what? Primes. Then it goes from the top right to which one? The red one, or the bottom right. Okay, very good. So to get from the top right to the bottom right, what transformation did they use? Reflection over the x-axis. Okay, so that's the first thing. You need to be a little bit more specific. You got to be specific. I want over which axis too. So reflection over the x-axis. Okay, and then to get from red to, I don't know, I think that's purple I got there, but those bottom left, what did they do? Good. A translation. How do you know that one's a translation? Okay. It didn't get flipped around, okay, because it has the same, what vocab word? Orientation. It's congruent, and it has the same orientation. Okay, good. Those two things. So now we have to be specific with our translation. We have to write a rule. Remember, it's x, y translates to what happened? Did it go up or down? X minus 6. Why did you say that, Tim? One, two, three, four. Okay, you have the right idea, but it's just, yeah, it's 5. When it goes to the left, it's negative. So we say x minus 5. How about y? Just stays the same. It doesn't do anything. It's just y. Okay, very good. Questions on how we might use multiple transformations today? I'm not going to spend a lot of time up here because you've seen all these transformations, and then it'll give you more time to work today. Okay. Here's all of your rules. This is actually a great page if you forget them all, and instead of going to each of the lessons where we wrote them, they're all right here on one page for you. Okay? If you make sure you have that. Okay. And another thing that I like to do is actually write the rules. So reflection in the x-axis, it says same order, so the x and y are the same order, but it changed the sign on the y-coordinate. So what would that rule look like? What ordered pair rule would that look like? X, negative y, x opposite y, good. Okay, how about for reflection in the y-axis? It says same order, change the sign on the x-coordinate, Kim? Negative x, y. Okay, 90-degree rotations. You have 90-degree clockwise rotation. It says switch the order and change the sign on the new y-coordinate. Okay, on the new y-coordinate, they want you to keep the y negative x. That's our new y-coordinate. And so it's a little confusing as to the way it's worded. You just have to think new y-coordinate. Okay, and then 90 degrees counterclockwise says switch the order, change sign on the new x-coordinate. Negative y x. 180 degrees, same order, change both signs. Same order, so it's still xy, but change both signs. So it's negative x, negative y is your rule. Okay, and then here's your translation rules. Okay, it's, if I add to x, it goes to the right. If I subtract from x, it goes to the left. If I add to y, it goes up. Subtract from y, it goes down. And then the only other one that we don't have on there is dilations, but what was the only thing that we did with dilation? You just multiply every number by the scale factor. Okay, good? So this might be a page you want to keep handy if you forget those. Okay, so we have a line. Okay, it says line AB. Reflect the line segment over the y-axis, then translate it using the rule xy translates to x plus 3, y minus 1. Okay, so that's the first thing we do. Reflect over the y-axis. Okay, how do I reflect over the y-axis? Well, first I need to find my y-axis. Okay, that's our vertical line. That means how far is each point from that axis? Go the opposite direction. Okay, so A is how far from the y-axis? 1, 2, 3. Then to reflect it, I go the opposite direction, 3. 1, 2, 3. And I have A prime. Same thing with B. How far is B from the y-axis? 1. So I go 1 the other direction. I have B prime. I connect my 2 points. And I have my new image. Okay, am I done? No, because then it said to translate. So now I need to translate. X plus 3, y minus 1. That means what? Kim? Which direction 3? Right 3. So at each point, 1, 2, 3 to the right, down 1. And that's A double prime. That's my next one. So every time I'm doing this, I'm doing it from the previous points. I'm not going back to the start and going right 3 and down 1. It's from the last shape that I did. So right 3, down 1. Then I do the same thing with B prime. Right 3, 1, 2, 3, down 1. How do I know it's right 3? X plus 3. How do I know it's down 1? Y minus 1. Okay, so I label this B double prime. Connect my points. There's my final image. Any questions on those two reflections? Those are a reflection and a translation. Those ones probably didn't need to write down the ordered pairs. You could do it. But once we start doing rotations, you're going to want to write down ordered pairs so you don't make mistakes. Okay? Then it has some questions. It says, is the original figure, which one's the original? Blue one, no primes, right? Okay? Congruent and or similar to the final image. So I'm looking at the blue one and which one? Green. Okay, the original figure. Is the original congruent or similar to the green? What does congruent mean? Same size and shape. Are they the same size and shape? Yes, they are. So it's congruent. Okay, so that's what you can. That's your explanation too, because it says to explain. So I'd say same size, same shape. I like this second one. It says compare the orientation of the original to the final image. What is orientation? That's that. I've asked you many times about orientation. Orientation means what? Evan? Okay, the direction that it's facing. Good. Is the direction that it's facing change or stay the same? It changed. What caused it to change? Anybody know? The reflection. Does the translation cause it to change? No, it was the reflection. Okay, very good. So the orientation changes from the original. I'm going to say due to the reflection. That way I'm showing I know what caused it to change the orientation. Okay? The reflection caused it. The translation wouldn't have changed it. Okay? Questions on that page? All right. Let's go to the last one. Then you'll get about 20 minutes working your homework. Rotate the triangle 180 degrees around the origin. Dilate it by a scale factor of 2. So a couple things again. First, we're rotating 180 degrees around the origin. Remember, when we do rotations, this is when I probably want you to write down your ordered pairs. Your ordered pairs are going to help you. So let's write down the ordered pairs for DEF. Okay, DEF. Actually, I'm going to write it over here because that's where our question is going to go. Okay, so D, E, and F. What's D at? Other way around. 2, 3. Yep, you want to write the x coordinates first. 2, 3. E. Good. And F. Good. Okay, now we have to remember the rule. Without trying to go back to that page where we had all the rules, the rule for 180-degree rotation, change both signs. Very good. Okay, so that means D prime is going to be -2, -3. E prime, -3. Oh, good, we can't have -0. That's right. Oops. Okay, and F prime, 0, -1. Graph them. -2, -3. We get D prime. -3, 0. E prime. And 0, -1. F prime. Aren't exactly on the lines. What do you mean by that? Oh, yeah, I don't know. This graph didn't, I don't know. They're not right here. Yeah, I know what you're saying. So if it helps you, sometimes you just got to kind of count anyways and see where the numbers are compared to where the lines are. Yeah, I don't know why this one didn't print out like the other ones did. Okay. Questions on the 180-degree rotation? Okay, the last thing you do, scale factor of 2. Okay? And scale factor of 2 means we do what? Times everything by 2. Multiply everything by 2. Okay, so D prime is going to become what? -4, -6. That's what our scale factor of 2 says to do. E double prime, -6, 0. And F double prime. Okay? So -4, -6. And that's D double prime. -6, 0. E double prime. And 0, -2. F double prime. Good. We have a lot to talk about in this. Is the original figure congruent or similar to the final image? Similar because? Good. Different size. So you say similar, it's the same shape, different size. And then the last thing, the orientation. Similar, or did it stay the same, or did it change? It did change. And what caused it to change? The rotation. Is the dilation going to change the orientation? No, it's just going to make it bigger or smaller. But the rotation did change the orientation. Okay, so the orientation changed due to what? Due to the rotation. Good. I think you guys did all right there. Okay. Any questions? Okay, you have some of these to try in your homework. I do want you to notice Wednesday we have a quiz on these transformations. So you're just going to be doing transformations on that quiz. Okay, so if you don't know some of the rules, you may want to start studying some of those. Okay, like our rules for a 90-degree rotation, 180-degree rotation. Okay, make sure you start studying those for Wednesday.